we are going to find the sides of right triangle. So we're going to find the missing variable in each of the following right triangles below. Round each answer to the nearest 10. Well, if we look at A, how can we find y? The missing side in a right triangle, what can we use? Pythagorean theorem, right? What Pythagorean theorem is what?
A squared equals C.
Yeah, a squared plus b squared equals c squared. Which one has to be our c? The hypotenuse, the one across MR90, the long side. Does it matter which ones are A and are B?
No.
Nope, I'll make that A, make that B, that doesn't matter. So when we plug it in, A is 8, B is y, and C is 12. So we get 8 squared plus y squared equals 12 squared. Then we just solve for y, so clean it up. What is 8 squared? What's 12 squared? What do we have to do with this 64 to get y by itself? Subtract it. Good. What's 64, or 144 minus 64? 80. And then what do we have to do to both sides? Square root. And when we square root 80 rounded to the nearest 10th, what do we get? 8.9? So y is about 8.9. There you go. I'm the missing side of a right triangle. But what about B? What about B? How are we going to find W? What can we use? Can we use the Pythagorean theorem? Why? We only have one side, right? We only know that this side is 17. We have absolutely no idea what this blue side is. It's not 54, that's the angle. So you won't do W squared plus 54 squared equals 17 squared. 54 is representing the angle. We can't use the Pythagorean theorem to find this missing side. So there is a way. Okay, there is a way. Sometimes we can't use the Pythagorean theorem. Okay? Just like we saw in this example, the Pythagorean theorem would not work for B because we only have one side. If you use Pythagorean theorem, you have to have at least two sides. Okay? So, when this happens, when you're only given one side in a right triangle and you need to find a missing side, we can use those trig ratios. We can use SOHCAHTOA. Remember, SOHCAHTOA is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. SOHCAHTOA. You can also use your formula sheet. Lots of ratios on there as well. Just on when you take like the ACT and things like that, you won't have the formula sheets. You have to remember SOHCAHTOA for that. So here are your steps. Okay? What you're going to do is start with the angle they give you. They will always give you an angle. Start with that. Okay? Then you're going to identify the sides as your opposite, your adjacent, your hypotenuse, just like we've been doing. And we're going to use those ratios to set up an equation and solve. Okay? So if we take a look at this first example, we want to find W. We're going to go back to that example from 1, where we want to find W. Start with your angle. They gave me 54. That's the angle I'm starting from. That's the angle I'm putting my pencil on. Then I go across from that angle, and we label that side as our what? Our opposite. So directly across from the angle is our opposite. Go to the 90-degree angle and go across. That's our what? And what's our side left over? Adjacent. We want to find W. So what you have to do is figure out, well, what ratio am I using? In other words, what two sides have info? Which one has my variable? Which one has a number? Which side has my variable? Opposite. Which one has my number? The hypotenuse, right? Opposite has my variable. Hypotenuse has 17. Well, if I look at this box up here at SOHCAHTOA, Which one has an O and an H? Which one has opposite and hypotenuse? Sine. So we're going to use the sine ratio to help us solve. We don't really need, we do need our laptops, but just make sure we're following the notes. While we typing on our Chromebook right now. Thank you. So we're going to use the sine ratio. We're going to say sine, that's the ratio we're using, of our angle 54 is equal to opposite over hypotenuse, W over 17. So we set up an equation. So we need to solve this equation. Okay, we need to solve for W. There's this little saying I like to use. Okay, when your variable is up high, we multiply. So my variable's in the top of my fraction. So I'm going to multiply by whatever in the bottom. So I'm going to multiply both sides by 17. When the variable's up high, we multiply. So we multiply both sides by the number in the bottom. That way it cancels out. W is now by itself. W is equal to whatever 17 times the sine of 54. We then need to plug that in our calculator to figure out what W is. I'm going to show you both ways. I'm going to show you Desmos and I'm going to show you graphing calculator. This is super important. If you're using a graphing calculator, what you need to do right now, so if you have a graphing calculator, I'll get it out. You need to hit mode. You need to hit mode. Give me a minute to get your calculator out. You need to hit mode. And you need to make sure your mode is in degrees. You need to arrow down so it's flashing on radians. Arrow down so it's flashing on radians. And then you arrow over until it's in degrees. So it's flashing on degrees. And then you hit enter. Now it's in degrees. To get out of this, you just hit second mode. You need to remember this because when you take your OST in the spring, we have to clear your calculator and it automatically puts it into radians. You have to be in degrees to get the right answer. So if you are nervous that you're not going to remember this, I'll show you how you can use Desmos in a second. Okay, but this is how you use it in your graphing calculator. If you're planning on using Desmos, I'll show you that in a second. So all you have to do is just type this into your calculator. You're just going to do 17 times sine. You just go to where the abbreviation for sine is. It's right here. It's highlighted in red. Sine, and then you type in that angle. 17 sine of 54. And you hit enter, and that will tell you what that side length is. If we round that to the nearest tenth, that side length is about what? 13.8. So W is about 13.8. How you would use Desmos? How Desmos works. Okay. You are going to type it in the same way. 17 times. To get those sine ratios, you are going to go in Desmos. You are going to click function. You also have to make sure you're in degrees as well. So if you hit this little tool, hit degrees. It's really nice. The state calculator, Desmos calculator that you are going to use on your test is automatically in degrees. So this is why I urge you, even if you have a graphing calculator, If you're doing a trig question, just use decimals. This is automatically in degrees. You don't have to worry about changing the mode or remembering how to change the mode. Just use decimals because it's going to automatically be in degrees when you use the state calculator. So you're going to hit functions, and then you just select sign. And then you type in 54. And you get the same thing, 13.8. I highly suggest you use decimals. I'm going to use decimals because I want you to use decimals. Okay, but I want to also show you how you can use your graphing calculator. Okay. So let's go ahead and try B. Again, start with your angle. Label your sides based off your angle. If we go across from 39, that's our what? Opposite. Go to your 90, go across, that's our what? Hypotenuse. And the side left over is adjacent. Which two sides have pieces of info? Which one has my variable? Opposite. Which one has my number? Adjacent. So we have our opposite, we have our adjacent. If we look at SOHCAHTOA or your formula sheet, which one has an O and an A? Tangent. T. So that's what we're going to use to set up our ratio. We're going to say tangent of our angle, which is 39, equals the opposite, which is x, over the adjacent, which is 15. Our variable is up high, so what is that saying? What are we going to do? Multiply. So we're going to multiply both sides by 15. So the 15s cancel out. X is all by itself. We're going to plug 15 tangent of 39 in your calculator. I'm going to use decimals. I'll show you your graphing here in a second. So I'm just going to do 15 times, go to functions, tangent 39. If we round that to the nearest tenth, our answer is about what? 12 point, what? Nearest tenth, one decimal place. What does the 4 do to the 1? 12.1. And to plug that in your graphing calculator, you would have done 15, hit tan for tangents, because that is the tangent abbreviated, 39. So the sine, the cosine, and the tangent on your graphing calculator are all right there. Just put those. Questions over that. So you have to remember, x up high, we multiply. Let's take a look at example 2. Again, we want to find this missing side. Can we use the Pythagorean theorem for this? No. Why not? There's only one side, right? So we have to use trig. We can't use the Pythagorean theorem. So start with your angle and label. Go across, that's our what? Opposite. Go to your 90, go across, that's our hypotenuse. Side left over, adjacent. And again, I'm going to write SOHCAHTOA. It'll let me. At the top of my paper, or you can flip back, or use your formula sheet. Which two sides gave me info? Which side has my variable? Which side has my number? Yeah, hypotenuse and adjacent. Which one, if I look at SOHCAHTOA, has a hypotenuse and an adjacent? What is it? Cosine. So we are going to use cosine. So I'm going to say cosine of my angle equals adjacent over hypotenuse. That's the ratio for cosine. 4.5 over W. The variable this time is down low. No, you're not. No, you're not. The variable this time is down the saying I like to use is switch a row. X down low, switch a row. So what we're going to do, what that means, is the variable and the cosine, sine, or tangent, the W is going to switch with this whole thing. They literally trade. So it becomes W equals 4.5 divided by the cosine of 33. And then you plug that in your calculator. So variable down low, switch a row. So I'll do it in Desmos. To plug it in, you're going to do 4.5 divided by cosine of, what was our angle? 33? And that side is roughly what? 5.4 when we round to the nearest 10. In your graphing calculator, you would just do 4.5 divided by cosine 33. And hit enter. And you get the same thing, about 5.4. Okay. Let's try B. Then label, circle the angle they gave you. We can't use the Pythagorean theorem because you only know one side. You have to know two sides to use the Pythagorean theorem. So let's label. If we go across, that's our opposite. When your 90 go across, that's your hypotenuse. Side left over is the adjacent. Which two sides gave us info? Opposite and adjacent. Which one are we going to use if we know our opposite and our adjacent? Tangent. So we're going to say tangent of my angle, which is 32, equals the opposite, opposite, which is 9, over the adjacent, which is x. Where's our variable? Up high or down low? Down low. So we are going to switch a row. So the x and the tangent switch. The tangent and the 32 are connected. So where the tangent goes, the 32 goes. And then you just plug that in your calculator. In Desmos, it's just going to be 9 divided by, well again, go to function, tangent, what's our angle again? 32? 32. So it is about 14.4. And you should get the same thing if you're using your graphing calculator. Questions on that? So, we can also use trig to find angles. Sometimes we're going to need to find an angle in the right triangle, and the angle sum theorem is not going to work because it didn't give us all the angles. Okay? So, we're going to use the same steps as if we're finding sides, but how we plug our answer in to the calculator is a little different. So, we're going to take a look at that in this next example. We want to find the measure of each angle, round our answer to the nearest 10. Because remember, when you take the sine, cosine, or tangent, you're always taking that of an angle. So A, in this first one's representing an angle. We just don't know what it is. Well, we can use our calculator to get a rough guess, or rough rounded measure of that angle. So to do that, you are going to use the inverse. I'll show you how to do it in Desmos, and I'll show you how to do it in your graphing calculator. So if we want to find the measure of an angle, and we are taking the sine of it or cosine or tangent, and we know the ratio. So the sine of an angle equals a fraction or a decimal. You can find the measure. In Desmos, what you're going to do, right, or essentially what we're doing, is taking the inverse of sine on both sides. And that's just the sine to the -1. I'm going to do that, and it's a little cramped, on both sides. That cancels that out. So I'm just taking the inverse sign of that fraction. So what you're going to do in your calculator, you're just going to go to functions, and you're just going to pick the sign that has the -1. And then you're just going to type that fraction, 8 divided by 10, in your calculator. And the measure of that angle is about what? 53.1 degrees. So A is roughly 53.1 degrees. Same thing here. We want to find the measure of angle B. So what we're going to do is just take the inverse of cosine on both sides. So cosine inverse here, cosine inverse here. That cancels out that cosine. We're left with B equals inverse of cosine of 7/25. To do this in your graphing calculator, I forgot to show you in your, I'll do the graphing calculator this time. To do the inverse in the graphing calculator, you're going to hit second, that blue second button, and then hit cosine. Same thing, you'd hit second sine, second tangent, and then type in that fraction, which was 7/25. And then hit enter. And the measure of that angle is roughly what? 73.7 degrees. So B is about 73.7 degrees. And the same thing. What are we going to do on both sides to find the measure of Z? Take the inverse of tangent on both sides. That cancels out. So we have the inverse of tangent of 2.4. So in your graphing calculator, you just hit second tangent and then type in that decimal, 2.4. And that is about 67.4 degrees. Again, in Desmos, you would just go to functions, hit the tangent that has the -1, and type in the decimal, 2.4. Gives us an answer. Questions over that? So we can use this and setting up the trig problems just like we did with the sides to help us find the measure of missing angles. And these two, we want to find the measure of angle x. We don't know what it is, that's what we're trying to find, so that's the angle we're going to start with. We are going to start with x. And then we are going to label our sides. Right? If I go across, that's our opposite. Go to our 90, go across, that's our hypotenuse. Side left over our adjacent. If we look at SOHCAHTOA, which two sides have pieces of info? The opposite and the hypotenuse. So which one are we going to use if we have our opposite and our hypotenuse? Sine. So we're going to say sine of our angle, which is x. We don't know what it is. Equals opposite, which is 6, over the hypotenuse, which is 10. This time around, our variable is an angle. So when the variable is missing, it's not a curse. We use the inverse. You're going to do exactly what we just did in that above example. Our angle is missing. We want to find the measure of that angle. So we use the inverse. So we just do the inverse of sine on both sides, cancels it out. You plug this in your calculator. In Desmos, you just use the sign with the -1. You go to functions, you hit the sign with the -1, plug in that fraction, 6 divided by 10. What did the directions say to round to? Here's 10. So the 36 point what? So that angle's about 36.9 degrees. In your graphing calculator, again, you would just hit second sine. 6 divided by 10, and you get the same answer. Questions over that? It would be the same steps for B, but I want to talk about one tiny thing real quick. So this same steps for B, we'll get the same steps here, but I want to talk about sometimes we use the variable theta. That's pronounced theta. Okay? To represent an angle, you'll see that a lot. Theta is just like any other variable. It's just like x. So when you're asked to find the value of theta, theta just likes to represent angles a lot. It's just a variable we use for angles. So it's no different than x. So in this example, it says find the value of theta. That's no different than saying find the value of x. Theta is in this angle. That's where we're going to start with. Label your sides. If we go across, that is our opposite. Go to our 90, go across, that is our, and the side left over. We look at SOHCAHTOA. Which one are we going to use? Which two sides have pieces of info? Cosine. We have our adjacent. We have our hypotenuse. Those sides have info. Those sides have numbers. Okay? So we're going to use cosine. Cosine of theta, because that's what we're trying to find. Theta is just representing an angle. Is the adjacent over the hypotenuse. 12 over 13. We're trying to find an angle. The angle's missing. It's not a curse. What do we use? The inverse. So we just use the inverse of cosine. Cancels out. So theta is equal to whatever the cosine inverse of 12 over 13 is. And Desmos. Go to functions. Go to cosine with the -1 and do 12 divided by 13. And to, what does it say to round to? 10? What is that to the nearest 10? 22.6. So theta is no different than writing an x. It's the same steps. Okay? Questions over that? Alright. Did get through everything, we got through the important stuff. So we'll finish. We'll probably lead off with like one or two of these examples. You have extra practice tomorrow, and then a quiz on Friday. At least for my class. Nope.